Hey guys, can I join you? Hi, this is Jim Bounds with Motorhome Rehab Ranch, and this is maybe the ranch. This is Cooperative Motorworks. This is the main building in our shop. And hot today, it's 80 degrees. Sorry guys up north, get the fans on. What can I tell you? Listen, this is episode 3.
Yep, three.
Episode 3 of Shocking GMC Electrical Systems. Well, I'll give you guys credit. On Facebook, if you're involved in that thread, awesome. This is what we want to do. You know, Henry Ford once said, a bump is as good as a knock. At least they're talking. Well, we've generated a great big thread or more about batteries. Good subject. Oil, tires, gas, good subjects too. But there's not just one answer to any one of those. And there's not just one answer to batteries either. And one thing that was reiterated over and over, actually 2 things. One, what I have works and I'm happy with it. The other one is, well, I'm not set up for that and I don't need that. Okay? So that's the right idea. If it works for you, awesome. Don't throw money and do something else. If it works for you, great. You got it upside down and backwards and you like it, baby, that's great. We live in America. The system needs to be set up to the way you're going to use it. Batteries have different charge rates. They have different discharge rates. They're made for different applications. You want to be sure you get the battery for your application. And I think that's what that all proved out. And that's great. Some people liked some of the things I've said. Some people didn't. Some people said, whatever. Well, at least we're all talking. I want to keep that going. So video has done this. Well, today, I'm going to talk about AC systems. Well, there was a good reason that Tesla beat Edison on electrifying America. If you try to send high current down a DC circuit, you're going to have a big cable like this because you're sending current. And there has to be small resistance for a DC system. So the problem is, if they tried to run all of the electricity in America today on DC, there's not enough copper in the universe probably to make that to go. AC, you can take a much smaller wire and do the same amount of energy with a much smaller wire. Yeah, it's a shame Tesla's not still around. I'd love to talk to him. What a cool guy. But AC won out because you can send more current on it. Okay, so AC is relegated to mainly higher current devices. AC doesn't store very well. You can't store a bunch of capacitors in line. If you do, they'll discharge in like what, 4 milliseconds or whatever. DC is easier to charge and store something. AC does more energy. Okay, so now in Europe, you guys watching in UK and all of that, caravans there, most of them don't have AC power because they're living in nature, right? I mean, you know, you open the vent and you see what temperature is outside. Us Americans have created motorhomes that are third world countries that once you go in, you could be anywhere USA. I mean, things are amazing. And there's a good need for that. That's great. But that's not what we are. That's not what a GMC is. But we do have AC power. So when they take some of our coaches to Europe, they're the Mac Daddies because they've got air conditioners. You know, other guys may not, I'm sure they're better now. They probably have them now because, you know, generators have gotten smaller, air conditioners have gotten more efficient. I mean, everything's just going crazy. So we have an onboard APU. I like that term, APU. Kind of scares me thinking about space or something. But it's auxiliary power unit or generator or whatever. Well, sorry about the glasses. I know they're cooked. So our APU, the original O&N, or, you know, some of the early 73s had some Kohlers that were painted gold. If you have one of those, I'm sorry. There were 4,000 and 6,000 watt AC generators. Now, if you wonder, well, what's the generator? Look in the left rear corner of your motorhome, you'll see one. I call them trolls. It's a beautiful World War II design. Works great until it doesn't, and when it doesn't, it gets old and contrary. And if you're fixing the thing every week and all that, I mean, 40 years is a long time for a generator to be around. You don't see a generator at American Red Cross waiting for disaster relief. And the definition of a generator is an emergency standby device. Okay, we have a generator on board, and we also can pull power from outside, whether you call it shore power or washer plug or whatever. So we have two sources right now to get energy: AC, alternating current, 120 volt, 60 cycle energy into our coach. The appliances that run on that, basically your air conditioner, microwave, excuse me. If you still have one of the built-in vacuums, that runs off of it. Outlets and things, blow dryer, whatever. The circuit in the coach, and there's a circuit breaker in there that they're all runs through a series of them. You need at least 30 amps to fire up an original roof air. Okay, we call those roof shakers. Turn them on, then the older it is, the longer it takes. But at some point, the compressor kicks in. Your thing, they still cool, but it's hard to sleep. Newer air conditioners, some people say they're not as effective, but they're getting pretty good. They're a lot quieter, and they pull so much less current. I mean, you only need. I've seen roof airs 13.5 run on a 2,000 watt generator, Honda EV, not EV. What is the Honda EU 2000 or a 3000? But you need 30 amps to run a roof air. You need at least 15 or 20 amps to run your microwave. Remember, you have a power converter, a power charger on board. The original one, the buzz box, big gray thing, you plug it in, and get rid of those. They're dangerous. But generally, a new style power converter will pull about 4 or 5 amps from the system. And then peripheral things, but those are the main current things. Now, you need to have, you need to have 30 amps of service from shore power. That's the 3-prong, right? If yours has 3-prong, that's a 30 amp box. Some of us have 4 prongs, right? You got a ground, neutral, and 2 hots. That's a 50 amp service. If you have 4 prongs coming out of the coach, you have what's called a split box. If you look at the breaker box inside, there'll be 2 rows of breakers. One side is on one leg of the 50 amp, the other leg is on the other leg. If you have 3 plugs, three wires on the connector, you'll only have, it's a single service, and all the breakers are off one leg. Reason I tell it to you this way, you need to be sure to tell a journeyman electrician or any home electrician that this is a single leg system. To him, 50 amp is 220. And you could plug it up to it, but it could be a smoke test. Okay? What you want to be able to do is you want to have either, if it's a 50 amp, okay, you got 2 legs of hot coming from the same source in the circuit breaker. Make sense? You'll have 2 breakers that say 20 or 30 amps, and you go to each one of the black legs. Neutral is both of them are the same, the common neutral. You don't have to have 30 amps or 50 amps to plug in. You can use adapters or dog bones where you go from a 50 amp 4-prong to a 30 amp 3-prong. Okay? Now, say you're at somebody's house and all you want to do is run the lights and the charger. You can go to another adapter that goes from a three leg 30 amp down to a regular 3-prong wall outlet, which usually are 15 or 20 amps. If you use a nice heavy cord, you can use 2 adapters and you can plug in your coach on that. But understand, don't use the roof air, don't use the microwave. And I would turn off, if you have an electric hot water heater, I would turn that off too. But you can bivouac, if you want to call it, in your friend's driveway overnight with just a regular extension cord. It's not turning it on. Okay. Talked about circuit breaker. Now, in your house, there's a box, there's a door on the front of it, and in there are breakers. And sometimes they're actually labeled. You can see what it means. And I don't know what it is. You know, I look at breaker panels, and people just don't seem important to label what the breakers are. It's just, I don't know what it is. But anyway, AC comes in the main plug, okay, from the generator. How does it do that? If you look inside the utility door, there's a plug there. This long plug with a cord on it plugs into there. That's on a regular GM floor plan. If you have a receptacle that looks like this one, that's where it goes. Fire up the generator comes out of this receptacle, goes into the plug, through the circuit breaker. Now you're running on generator power. Now, this is the original. This is how the original was set up. If you have a Coachman, you know, Avion, Norris, or Birchhaven, a lot of those had different electrical systems because those were wired by the RV industry. There wasn't much of a standard. And if you have a 30 amp coming out and you don't have any plug or anything like that in your coach, in at your circuit breaker will be two breakers with a bar in it. The bar will only allow one to be on at a time. One will be generator, one will be shore power. Okay. If that bar ever flips, you probably have some damage. So that wasn't a really good idea. Whenever we get a coach in that has one of those kind of switches, we'll put an auto transfer switch in. What that does, it will watch for the generator. When you fire the generator up, it'll give it a minute, and then it will automatically, with contactors, close in and run the living area electrical system on the generator. When you turn off the generator, it opens, and now the shore power can work. You say, wow, that's easy. Yeah, you don't have to plug it in or anything like that. It is true. And if I was building a party machine where probably half the people are going to be drunk anyway working at it, or I'm building a luxury vehicle or something like that, transfer switch is a good idea. And you really want to have something nice, you put a transfer switch in. But let me explain. Having an outlet on the wall and a plug plugged into it, there's not much to go wrong with, right? Am I right? You induce a transfer switch into the system, you have one more failure point, okay? And if the end goal of this thing is to be as reliable as it can be, you may or may not want to do a transfer switch because when that goes out, brother, you got basically nothing, okay? In many ways, I like the idea of a manual plug-in because there's no problems with it. Now, the original Amazon cord you got that took 50 amp, there's some new wire. There's some new wire you can get. Hughes Supply. I use 8-gauge 4-conductor SOW. SOW is fine thread, wires, very flexible, and is smaller than the original 50 amp cord. It's still 8-gauge, and it'll run it, but it's much more flexible. So when someone asks, that's what we'll do to change that. As far as the power converter, we've kind of beat up the power converter on earlier episodes of this thing, but power converter is very important. Power converter takes 110 volts. It's a charger. It takes 110 volts, creates 12 volts to charge your batteries and run your lights and all that. And brother, if you lose DC power, party's over. Can't go anywhere. You can't turn on any lights. Having a charger on board is very, very important. That's why you want to have a late model, high quality, 2-stage where it won't blow the batteries out and all that kind of stuff. Shore Power makes a real high-end unit that'll desulfate the battery plates and all this kind of stuff, give you amp hours. If that's what you want, if you're a pilot and you've got to have the information, I'm good with it. You don't have to have that, as long as you can see what your voltage is. If your voltage in your living area is above 12.65 volts, which that's a fully charged battery. If it's, 13.1 is a fully charged battery with a top charge on. But if you have a voltmeter, which we build in the restorations, and your battery voltage is 32 or 34 or something like that, your charger is working. You got to know how well it's working. You can get some other meters and things, but that's not needed. Just need to know what your voltage is. Are you charging? That's the important thing. And if you are, then you have DC. And AC supplies that, whether you're plugged in or in the generator, right? So AC is very important to our lives because we live around it. Think about it, you're at the house watching the news or something, the power goes off. You sit there for a minute and look around. What do you start doing? You go for a candle. It's the middle of the day, so you go light a candle anyway. What the heck, right? We live around energy. And we use energy. Us Americans, we're energy suckers. We are about the grid. Okay? We're about how much energy do we have on the grid. We've got a house in Ormond by the Sea. It's got 50 amp service to it. Built in 1953. Got to be careful on air conditioners and stuff like that. Most houses today are 100, 150, even 200 amp service. So you can run a lot more things. In your motorhome, if you have two roof air conditioners, you have two, you really need 50 amp, or you need a 6,000 watt generator or 50 amp service. If you only have one, you can get away with it with today's 4,000 watt generator. And if you have new roof airs and stuff, you might even be able to go with a smaller generator than that. But let's use it a gauge. If you have one roof air, you need 4,000. If you have two roof airs, you need 6,000. Okay? General Motors put 4,000 and a 6,000 in the GMC in the 23 or 26 first year. After that, they realized that most Americans, fatter tires, bigger steaks, gas guzzler. Everybody wanted 26s. So there were only 15% of the GMCs built in 23. Most of them were in 73 when they found out, oh, they want the big ones. Most of the generators, 4,000 watt generators, were in the 23s. That's all that would fit. I have seen some 73 GMCs with a 4,000 watt. After that, though, all 26s just about had a 6,000 watt generator, whether it had one roof air conditioner or not. If your coach had an MSO or manufacturer's delivery south of the Mason-Dixon line, it probably had two roof airs put on the factory. Because north of the Mason-Dixon line, it probably had one. But of course, dealers put other things in and all this stuff. So I wouldn't go just by that. But if you have, like I said, you need at least 30 amp service or a 3-wire to run one roof air conditioner. And then if you have two roof air conditioners, the 4-prong, we have two hots at a common neutral. The two hots, one will go to one roof air, one will go to the other roof air, and then all the other accessories will be pulled off of that. That's the way that split box will be set up. Okay. My mom knew that she was in big trouble. I learned about AC electric real early. I stuck a coat hanger in the wall socket. Found out about it right away. She came home one day. She was a teacher, a librarian, and I had hooked the radio to the phone. I thought it was awesome. We had call waiting. We had music. You pick it up. Of course, it was while you were talking too. So that's how I learned stuff by sticking my finger in the light socket. All right, AC electrical will hurt you. Don't do this. Right? I did because I know the other side of it. AC is dangerous. Dangerous stuff. In a home, there's some very, very stringent, serious rules, regulations to put in home AC. Unfortunately, in RV, especially in RVs in the 70s, there was really not much of a standard. Shoot, the Coachman Royales, if you have a Royale and you have a brown outlet plug, back away slowly because that's a Scotch lock outlet. They ran the wire through it and screwed it together and it made power. My suggestion, take that thing out and put in a real plug. Our coaches had basically no standard to their AC wiring, okay? So you need to look for chafed wires. If you have a short circuit somewhere or you pop a breaker, you really want to look at things that are unusual because it's been in a 40-year-old motorhome bouncing down the highway at 8.1 Richter scale vibration, you know. So you want to kind of inspect the wires, but if you look at them and they're in good shape, they did use 12-2 to the outlets and especially to the appliances. Today's standard is 14-2. This is 14-2 to outlets, but 12-2 still to the appliances. When I say 12-2, it's actually got 3 wires in it. You've got black, which is hot, white, which is neutral, and the ground. Open copper is ground. This is your safety factor. Some houses back in the 50s, 40s, and earlier were only wired with 2. Had no ground. The reason the ground's there, if there's a short somewhere, it'll pop the circuit breaker much easier. With a 2-wire, to pop the circuit breaker, you're going to have to like lick it or something. you have to have a smoke test. So our coaches are 3-wire. Okay? And if you add circuits, I would suggest to use 12 gauge. If you know it's going to be an outlet and it's going to be something small, you can run 14 gauge. It's a lot easier to run. But I would run 12 gauge. You want to run things straight. You want to run it straight down the wall, take a 90, and go straight over to the outlet if you have to, or straight like that, because maybe that way you can figure out where it is. You don't want to run 1 wire like this, cutting over here, and working together. You don't want to do that. You want to keep any of your circuits nice and clean and ordered, away from where somebody might put a nail in it, right, or anything like that. And you don't want to really have, you want to have home runs if you possibly can. You can hook 2 outlets together or something like that, but if you're going to run a circuit for a microwave, you want to be a home run circuit. That means 1 wire going to 1 breaker. Home run circuit. Very important if you're going with higher current things. You don't want to daisy chain them all together. Well, you cut them all at the same time and pop the breaker. Most of our coaches have the wiring overhead. 73, they ran on 26 foot. They ran a wire under the floor toward the front and put a piece of 1/4-inch plywood over it. If you staple your carpet down, you may have a problem there, Scott King. You may want to watch for that. So if you have a 73, look under the large window. If there's a wire that goes down, you may want to redo that. Okay, that's not a great idea. You want to keep all the circuits up and behind the cabinets, right where the headliner comes down and the wall comes up, right there. Okay, make that a wire chase. Have your wires run front to back right there. Okay, if you ever need to get to it again, they're all right there. You can put a cover over it in the cabinet. Originally, they had these little plastic covers. You know, they fall apart. If you have full cabinets, the only place that they would show would be over the door. See, make a panel go over the door. But run them front to back. If you put a new headliner in, run a couple of cross wires. You know, pull wires. You can run 1 across. If worst comes to worst, you can go all the way to the back and around and back. But if you're going to wire your coach, you got to do it. It's okay, but it's a big job. You may want to consider adding to what's there. That's a much more cost-effective way to go. If the bulkheads are in good shape, the plumbing's halfway okay, you can add to the plumbing, you can add to the electrical, you can add to the original wires. That's really the more economical way and cost-effective way to update the electrical system or any system to coach. If you're running wires, you don't want to get them near heat sources. You don't, well, all the normal stuff. I'm not going to sit here and give you all that crap. But, you know, this is real important. It's real kind of scary AC, and the wires need to be in a protected place. They need to be in a place that you can get to them and be able to test things or service them and stuff like that. Okay. One of the great things about the motorhome is you have all the things with you. You know, you can sleep in your own bed every night. You can have your own air conditioner. You can make your own pizza, your own tombstone pizza in your own microwave if you want to do that. You know, that's a great way to travel. You know, if you get tired, you pull over. It's a wonderful thing. Some people say, well, I want to have a real minimalistic view. I want my motorhome to be very stripped, ready for anything. Well, that's good. That's great. And a lot of people do that. No problem. But we like our creature comforts. You know, I mean, we're spoiled. You know, it's 80 degrees here today. We have the fans on. I'm sorry about that, Scott. I know. 20 below, wherever it is. Sorry. We like the weather. We need to have a temperate zone, you know. we like TV or monitor or internet or whatever you call that thing that gives you facial radiation and, you know, you learn stuff on. We like all this creature comfort stuff. Bluetooth. It took me a while to know what that meant. But we love Bluetooth. We love wireless. We love all this stuff. These things can be added to motorhomes. But remember, our world lives off AC. Okay? So having the ability to have AC appliances available, AC electronics available is really great. An inverter. Now we talked about converters. Make sure this gets straightened out. Converter takes AC, 120 volts AC, or if you're in Europe, you know, 50, sorry, whatever, let's not do that. Takes AC power and creates DC voltage to charge a battery to run lights. An inverter takes DC current, takes battery current, beats it up, and creates AC so you can run your appliances. We say, wow, fabulous. That'd be great. We could run the roof air with that, right? No, there, Ranger House. Can't do high current through an inverter. A power converter, 12 volts, from 110 to 12 volts, very efficient. Very inexpensive build, very cost effective. An inverter is very inefficient. A pure sine wave inverter, which sounds just about what it is, pure sine, accurate, clean AC signal. Pure sine wave inverter would run a roof air conditioner would take about 4 golf cart batteries and last about 2 hours. Okay? A pure sine wave inverter is very inefficient, probably about 40 or 50% efficient. It gets hot. One of the byproducts of current flow is heat, okay, resistance. When I used to do tech work for Lafayette Radio, we had a saying on the bench: current eats technology every time. What I mean by that, if you have a high current device and there's cute little electrical circuits controlling it, sooner or later this will eat that. It won't be the other way around. This high current device is going to eat this thing. Okay? So an inverter is a control board, cute little thing, controlling high current. Very unstable, very inefficient, gets hot, and they eat each other. Well, you say, well, we'll send it back. Well, when it eats each other, it may just fail. It may just burn up along with you and everything else. If you're going to use an inverter, you're going to be doing small appliances. I mean, you can run a wall to run your laptop or you know, stereo, or even a new flat screen TV. They don't pull anything. The old TVs, those were heaters with the picture tube. New flat screens, you can run those on a small inverter, and you can run it on what's called a modified sine wave inverter, which are much less expensive. You can get a 400 or 500 watt modified sine wave inverter for $100 or less. What's it run? You can run your laptop. You can run a TV system. You know, you can run some lights, all this kind of stuff. What can't you run? The microwave, the roof air conditioner, blow dryer. Pulls a lot of current. You know, those big ones, 1500 watt blow dryer. Well, it needs 1500 watts of power to work. So small inverters are pretty nice. They can do a lot of the low current things that we do today. But when you introduce a inverter into your electrical system, now you have yet another place that you could have a problem, another fail source, just like the transfer switch, a fail source. Don't tie everything through the inverter, because when it fails, everything will not stop working. That's just my personal biased subjective opinion. And they make combination converter inverters. What does that do? Does everything. It charges and it inverts both ways. So you got, to me personally, it's very convenient, very nice. I would prefer to have a separate power converter that's very efficient, never messes up almost, throw it in there and lock it away, and then have a separate inverter that's not tied to everything. Because when it fails, everything else doesn't fail. Okay? And again, this is a personal preference. I know this is I said this on purpose. So you guys get on the Facebook and get some threads. Oh, I've had an inverter charger for 15 years. Works great for me. And I'm excited for you. It's awesome. And I put them in too. I'm just saying that that's another failure source. And you need to look at that. You need to be effective and efficient. You don't need to buy a pure sine wave inverter converter to be more efficient or more reliable. Matter of fact, it's opposite. Okay. You want to work on it? It's okay. And they're not junk. They're super duper. It costs enough. They better be. Okay. I probably spend too much time on inverter converters, but that's okay. So with an inverter, now you have three sources of AC power. Shore power, generator, and the inverter. Okay? Generator is big enough you can run everything. You know, in America, we want to turn on every switch simultaneously, right? Want everything to be on. Well, 6,000 watts, you can do that. Shore power, if you've got 50 amps of service on the plug, you can do that. If you have less, you can't do that. Inverter, depending on how big it is, what you want to run, you probably want to run smaller stuff because running bigger stuff really pulls a lot of energy. And you certainly don't want to run one of those big inverters if you're dry camping or boondocking because it'll flatten all your batteries right away. You'll be back there with a stick and a marshmallow. You don't want to do that. So electrical systems, AC systems, and DC systems need to be designed the way you're going to use it, what you're going to need. If you're going to be off the grid, you don't want to go with the big AC circuit and all this stuff. You want to put a decent charger so whenever you can scab some AC, you can charge. Or whenever you run your generator, you can charge. You have a real good power converter. You may want to have a real small modified sine wave inverter, maybe a 500 watt or 1,000 watt, to charge your cell phone while you're out there in the Serengeti off your battery. You don't have to fire up anything to do it. That's a really positive thing. So you want to build your AC system and your DC system to how you're going to use it. And just like the Italian waiter said when you made your order, good choice. They're all good choices, depending on what you're doing. One thing you don't want to do is eat everything in the menu. Right? You don't put everything in there. That doesn't work. Whatever you feel works for you. Now, I was not a motorhome guy. I was an electronic. I've learned what I know about motorhomes from clicking my finger, finding out things. There are so many other ideas. There's so many other products. Seems like every week we have some new glue or some liquid that just makes your teeth brighter and women love it and all that kind of stuff. There's new stuff coming out all the time. So anybody tells you this is what they do, understand, take it as that. That's what they do. If that fits you, awesome. Do some due diligence. Look at some other things about AC electrical and DC electrical. Look at your manual. See what that thing's wired. See how it's wired. Understand what's going on. It looks like a big pile of wires, but the reality is, if you stare at the diagram a few minutes, it starts to make sense. It's not a big deal. These motorhomes are 40 years old, and they're not really complicated. We don't have an OBD computer on board. We don't have all that electronic nonsense that I have no idea about. I'm really kind of stressing out about having to buy a new car soon when my Suzuki takes it up because I don't want to buy anything that I can't fix. They don't make anything like that anymore. So, yeah, that's a problem. Well, look, give me some input about anything else you want to talk about, AC, anything like that. I have gotten a lot of your comments. Thank you very much. What is it? We've got a list of how many subjects we got?
We've got a list of about 7 subjects, from plumbing to lighting to AC.
Plumbing, lighting, AC, all the stuff. Awesome. We'll do that. You know, I'll put you out something, and I appreciate you watching. We've tried to make if it looked too complicated last time, look at the Patreon page again. Okay, what I'm interested in is for you to join our group and to have fun with us. Okay, and I'd like to give you one of these T-shirts. Send me $50. You got my phone number. Oh, you don't? 321-299-5707. My cell phone, it's on me 24/7. Please don't call me 2 in the morning unless you really need to. If you need to, don't say I'm sorry to call you. Say, Jim, I got a problem. That's what I'm here to do. Help you anytime. It's great. Let's get together. Let's get a little group going here. Can you afford to do more of this? We ordered a GoPro. Thank you, guys. We ordered a GoPro. We haven't done the microphone yet. We got, I don't know what model it is. What model is the one?
It is the GoPro LCD Hero.
Hero. The LCD Hero. Oh, boy. Can't wait to try that. And we're going to get into some more editing and things like that. I really appreciate your support. I really appreciate the comments you've given. I have a morning blog on the co-op website, which is GMCCOOP.com. You go there, look for the Daily Pose blog. I try to put something up there just about every day. Hey, UPS is here.
Awesome.
Is that supposed to pick those boxes up?
Yep.
Awesome. Great. We had some firefight stuff we had to get out. That was for you, Mac. Want to make sure it gets out. And so anyway, that's great. Well, that's what we have for today. You have
One more thing. Do you have a patron who was requesting that you go back in the archives and do a how-to video for some of your stuff and a how-to video for beginners?
Okay. We want to do some how-to videos on some of the stuff that's on the website. One of the ones I think that people really liked was, so you want to replace your window rubbers. That's for the guys that have the Style 2 windows. I'm going to work on that. That'll be fun. I'll do that one. And also for you guys early, I did a daily pose about how to do that, but I'll try to do a video on that one too. So look, thanks for coming. Thanks for listening. Tell your friends and get on Facebook. Yell at me. It's okay. But go on Facebook. Let them know what you're doing. Show people what's happening. Whether you agree or disagree, like I said, at least we're talking. That's what we want to do. So look, thanks a lot again, and we'll see you next time.